Hello everyone, welcome. I'm István Juhos from Fertig, and this is Compose Migration Side Effects. What can go wrong? First, let me start with some setup. So first, let me start with some food for thought. This talk is inspired by this episode of Dexter's Laboratory, which is a show from roughly 30 years ago. So if you remember it, then you're probably as old as me, or maybe older. I don't know. Old people are okay. And there is a specific episode called Lab of the Lost, and you will see how this corresponds to Android development and software development at all. So in the synopsis, there is this protagonist, Dexter, who is a boy genius, who stumbles upon his long lost abandoned part of his laboratory, his long lost inventions, which are neglected over time. And those neglected inventions, robots and sorts of things, actually turn on him and try to harm him. So probably at this point, you might have figured out the connection between software development and this show, this episode. Our code base is our laboratory. And eventually, when we are building our code base, the code gets bigger and bigger. We add more features, we add more, shortcuts and bad decisions. Our code base will grow. And eventually, some part of it will become our old lab. Of course, you might be lucky to not have an old lab, to have a new code base, to work somewhere where the coding just started. Well, good for you, but your current code base, which you are working on and building, has a really high chance, if the company succeeds, of becoming your old lab or someone else's old lab one day. So yeah, let's just be mindful when adopting any technology, but especially now that that everyone jumps on the Compose train. The first concept that I want to touch is code-based fragmentation. First of all, what is code-based fragmentation? Code-based fragmentation occurs when, in a relatively large code base, new things are introduced, new technology, new methodology, new architecture, and such. And the old parts get neglected in the process. So we have quite a history just on the UI part in Android in this regards. Back in 2008, Android was released. There were views. That was the basic thing, how we could build UIs. And then some years later, we got this thing, this ugly thing called data binding, which actually haunts a lot of code bases, as I've seen so far and as I've talked with people. So it just is everywhere. It's haunting. It was the brand new thing back then in 2015. Then, after a lot of things, a couple of years later, we got view binding. Some of us jumped on that train as well. So new things were added again to the old lab. And a couple of years ago, Compose reached 1.0, and everyone wanted to jump on that as well, and still wants to, because Compose is awesome. So obviously, we want to use Compose. We'd like to use Compose, whether it's a new project, whether it's an old project, we want to use it everywhere. But aren't we just adding to the code base fragmentation with Compose? That's a good question to have. And if you're at a point where you are considering migrating or adapting to Compose, then you're already at a good place. But there are things to consider. First things first, if you have a already large code base which, gives money or makes money for the company, then there might not be the resources, meaning work power, time, or the business case to rewrite your existing features with Compose, because why touch what is already working and providing the company money? It's a risk that you might or might not be willing to take as a company or as a team. And then again, you might not be ready on an architectural level to adopt Compose, because you might have some exotic setup, like So yeah, like binding view models to your views directly through the fragment, which is kind of exotic, or the whole app being built on epoxy. There are apps like that as well, of course. So you might need some extra refactoring in your old lab to adopt Compose. So if you're at a point with your application that is big enough so that you have modules already, because it makes sense, creating new features in new modules, new feature modules, library modules, and whatnot with Compose might be a reasonable direction to take to limit that code-based fragmentation. Okay, here is, well, now we can say textbook project that started with that is already on the way to modularization, but there is still the monolith. There are feature modules. There is something called shell or common on whatever that you might encounter, and all of this is pretty much legacy code from a Compose standpoint because there is no Compose yet. And yeah, this might be our old lab. What if we want to add Compose to it? Well, the easiest solution would be to write new features with Compose. We create a new module, we just include Compose in that module, and the rest of the code base doesn't know anything about Compose. That's quite easy to do. If we wanted to add some Compose code to the monolith, however, well, that requires more consideration because there is probably some view-based solution there or view-based solutions all over there. So mixing the view world with the Compose world might require some more planning and thoughts. And that's exactly the next topic, mixing views and Compose. Another thing to look out for. First things first, we can do that. Compose view interoperability is a thing, and it's quite good. It works well, and it's quite stable. So there is something to consider. But should we? That's the next question. Compose promises us that we will get rid of the need for context switching between the XML world and the Kotlin code world. Previously Java, now Kotlin code world. And just move towards writing pure Kotlin and composables, functions, and that's it. But if we want to mix views and Compose, we might introduce some new ways of context switching between the view world itself and the Compose world and the bridge between the two. And if we want to bridge over, we of course need to use the interoperability features. And there is this thing called Compose View, which hosts a composable. Actually, if you call set content on an activity, that instantiates a compose view and sets that compose view as the root of the activity. So actually, we are working with compose views probably at this point as well. The thing with compose view is that every compose view has its own composition. So if you have a lot of compose views on a view-based screen, then that might hinder performance, especially if you use composable as items of recycler views. But Compose is improving, and that might not be a problem anymore. Also, if you go down this route, UI tests need to be Compose aware as soon as we start mixing the view and Compose worlds. So that might require some extra work as well, based on the complexity of your testing setup. If you're just doing textbook Android UI testing with Espresso, then it can be a smaller change because of an activity rule. You'll just have to use a Compose rule, and that's it pretty much. And then you can access the Compose parts of your UI. But if you have something more exotic, again, like implementing the robot pattern or page object pattern, as it's known in other circles, then you might need to go deeper and touch your UI testing setup more extensively. Okay, if you're interested in Compose View interoperability, by the way, there is a good talk for it, and this is the place for self-promotion. Sorry about that, but this is a good topic to go into details about. Okay, our last topic of this talk is theming in Compose. because I've seen a lot of places, a lot of apps that struggle with this over time. But first of all, let's state that theming in Compose is really, really easy compared to what we are used to in the Vue world. With all the themes, styles, inheritance, and whatnot. Compose solves all of that by just not having it, obviously. More so if we use Material 2 or 3 as is. So if our application is purely Material, we don't want anything extra, anything fancy, anything custom, then theming in Compose is just a breeze. So let's see a textbook example of that. This is pretty much straight out just copied from the documentation. We create our own theme. We do some extra things there, provide some extra parameters probably, and then we just call material theme. The material theme composer will be the provided content, and we have a material-based we have the ability to create material-themed screens with Compose. Okay, on the use side, we use this demo app theme or our theme. We wrap it. We wrap our other composables with that, and then we will be able to access, well, properties from material theme. That one there. So this might cause some discrepancies. Of course, this is a textbook example again, but this just doesn't add up. We have our own theme. How come that we need to use material theme here? What is that? What that even means? Well, the thing is, that material theme that we use there is not a composable. Obviously, we couldn't use it like that. It's an object provided by the Compose material library, and that object provides us with a couple of composition locals or values provided by composition locals. And actually, it provides a quite scarce set of these parameters: shapes, typography, and colors in the theme, and that's all. That is because all of the other things that are needed for a design system to be, well, extendable or more versatile are actually implemented in the components itself, in the material components that we are provided by the material library. So what are those that we could be wanting to modify or reuse in other parts of our application? Well, a lot of things, actually. We could use custom spacings, custom dimensions every now and then, or if you want to implement your own like one-shot components with Compose in your application, then you might want to use you might want to use things from your custom theme, but you pretty much can't with material theme itself. Also, in a custom design system that eventually probably most of us will have, we would use semantic colors and sizes and typographies and just custom things that material itself doesn't provide us. So what we can do is we can implement our own object that provides our own composition locals. Why not? We can just copy what material theme does and the material library does and have our own take on it. So for this example, we have this data class called demo spacings. It would just have a list of custom spacings that we are using in our custom design system. We would have a composition local, again, a custom one with which provides this demo spacings, instances. And then we could implement our own object, which is called the same as our application's theme, and we could just, again, copy paste the implementation from material theme and provide our own spacing object here. And then on the use side, we now have a demo app theme, our app theme, and now we don't have any discrepancies, don't have any references to material theme anymore in our code because we can provide our own with our object there. Why does this matter at all, you might ask? Well, if you start out with material, with quick prototyping, of course, no issues there. But eventually, if as your app grows, eventually you will need custom components that keep their own visual appearance and behavior. So you opt for reusable components more and more as your app grows. And if you just base all of your things on material and composite material, what composite material offers you, then it will quickly become a burden to use material and customize material anywhere. Okay, so if you want to read about design systems, which I'm really keen on doing whenever possible, then you can check out the documentation from Google, and there are a lot of talks also on that topic. Okay, time is short, so I had a couple of more topics in mind, but maybe another time. Navigation. So there is the view-based Jetpack navigation library that probably a lot of us are using at this point, and a lot of applications have it because it was a big thing in the navigation space recently and in the last couple of years. And now we have Compose navigation, which is kind of the same thing, just in a Compose dress. But if we want to move between the two worlds, then we might need to bridge those two worlds manually currently. Or we could go with a decision that we want to keep Jetpack navigation on the view level because we already have that. And we can just keep activities and fragments and use them with navigation and just have Compose be the presentation layer of those activities and fragments and be done with it. We introduce Compose, but we keep the navigation as it is. Next thing, code organization. Composables are pretty much just functions. So if you make them small, make them reusable, that might make sense from a code organization standpoint or a normal function standpoint. But you just have to find the correct balance between many small composables that are probably reusable or probably not reusable, and readability and cohesion in your code. Yeah, every time you extract a sub part of a composable, think about that. Think about if it will be reusable actually or not, because if it probably won't be reusable, then just make it private and don't clutter the auto completion of your IDE for others in your team and for yourself, of course. Last but not least, create meaningful previews. Previews in Compose is a really powerful tool, actually a toolkit. So it provides an opportunity to really just manually test or see how your composables will look and behave in certain situations. There is support for different text sizes, different screen sizes, different screen densities, and now there is even an accessibility check in the Compose previews built in. So yeah, just create meaningful previews. Take the time to do them, and you will thank yourself later and your team as well. Wrapping things up, here are some resources that I used to create this presentation. Feel free to check them out. You will see them on the recording anyway. And with that, we reach the end. I'd like you to take two things, if nothing else, from this talk. One, always take the low effort precautions when adopting Compose or actually any technology, like with the theming, with the code organization, with the previews, and so on and so forth, because your future self and your team and your probable successors will thank you afterwards. And yeah, just think like your Compose code will become the old lab eventually, and make it as good as you can today. With that, thank you for your attention, and yeah, I will tend to the questions, or yeah, reach out to me on socials. You can find my addresses and everything and handles there on the right side. Thank you.
Thank you, István, for this great presentation. Like, I really enjoyed it. So we will have kind of short question part, but still So, for example, one of our listener emphasized abstract compose view. Yeah, that is really helpful. Do you agree with this statement? Yes.
Absolutely, I can double down on that. And if you check out that talk that I linked, there is a part about abstract compose view. You can really abuse it, by the way, if you re-implement your design system with abstract compose view. This topic is also in the talk. But if you need to create custom composables anyway and include them as views, then abstract compose view is a good choice, of course.
Thank you. And our last question, yes, from me. So should we rewrite old screens with views to compose, or if it's like isolated and there's some another module, we can leave it just be to the best times? And yeah, what is the best strategy?
Well, it really depends on your management and finance department. Of course, as an engineer, I would say that rewrite everything to compose and let's have a better future. But of course, as I mentioned, it requires resources. Your time is, well, if you're working for a company, obviously, and not yourself, then your time is booked. You're selling your time as a resource. So you might not, as a team, as a company, have the resources to do the full migration. If you're in a lucky position that your company supports a full migration, go for it, obviously. But you might have to find a balance between the new and old features, what to modify, what to not modify, prioritize stuff.
Yeah, supported. Thank you very much for this presentation. We will go to our next talk. Yes, I was happy to see you there. Bye-bye.
Thank you very much for having me.